In the darkness of space, Jupiter dominates everything around it, a massive gas giant whose size alone defies comprehension, large enough to swallow Earth more than 1,000 times over, with swirling bands of orange, white, and deep red stretching across its surface like vast, moving oceans. From a distance, it appears almost calm, almost beautiful, a silent world suspended in the void. But beneath that appearance lies one of the most extreme environments in the entire solar system. As an object begins descending toward Jupiter, the planet's immense gravity gradually takes control, pulling it inward with increasing force, turning a slow approach into an accelerating fall. Unlike terrestrial planets, there is no solid surface waiting below, no clear boundary separating space from atmosphere, only an immense envelope of gas extending thousands of kilometers deep, creating a descent that has no obvious endpoint and no moment of impact. The great red spot rotates slowly into view, an enormous storm system that has persisted for centuries, larger than Earth itself, representing just one of countless atmospheric phenomena driven by Jupiter's immense internal energy. The closer the descent continues, the more the planet fills the entire field of view, until the surrounding stars disappear completely, replaced by an overwhelming expanse of clouds that stretch endlessly in every direction. Upon entering the upper atmosphere, there is no collision or sudden transition, only a gradual immersion into layers of gas composed primarily of hydrogen and helium, mixed with compounds, such as ammonia, that form high-altitude clouds. At first, these layers appear thin and diffuse, allowing faint sunlight to penetrate and illuminate the environment with muted, alien glow, creating a brief illusion of calm that quickly begins to fade. The atmospheric motion becomes noticeable almost immediately, beginning as a subtle pressure before intensifying to powerful winds that move at hundreds of kilometers per hour, driven by the planet's rapid rotation and internal heat. These winds do not flow uniformly, but instead form complex, turbulent systems that shift constantly, eliminating any stable reference frame and replacing it with continuous, chaotic motion. As the descent continues, the clouds grow thicker and darker, reducing visibility and absorbing the remaining sunlight until the environment becomes dim and shadowed. The vibrant colors visible from space transform into deeper tones, with bright bands giving way to dense layers of brown and gray, creating an increasingly oppressive visual field that reflects the growing hostility of surroundings. Simultaneously, the atmospheric density increases, and with it, the pressure begins to build, exerting force on every surface of the descending object. At this stage, the pressure is still within a range that could theoretically be endured for a limited time, but it is rising continuously, with no plateau and no possibility of stabilization. Each additional kilometer downward introduces a measurable increase, marking a steady progression toward conditions that will soon exceed any biological tolerance. Temperature also begins to rise, following a pattern opposite to that of Earth's upper atmosphere, as Jupiter's internal heat becomes more dominant with depth. The environment transitions from cold and diffuse to warm and increasingly energetic, with clouds composed of ammonia giving way to deeper layers containing ammonium hydrosulfide and water vapor, each contributing to the complexity and intensity of the atmospheric system. Lightning becomes visible within these layers, not as isolated flashes, but as massive, recurring discharges that illuminate vast regions of surrounding clouds, revealing towering structures that extend for great distances and emphasizing the scale of the storms within which the descent is taking place. These storms are not temporary events, but persistent features of a dynamic system that operates continuously across the planet. With further descent, the pressure rises to multiple times that of Earth's surface, and the combined effects of increasing density, temperature, and turbulence create an environment that is no longer survivable. Movement becomes restricted. Structural integrity is challenged, and the conditions shift from extreme to fundamentally incompatible with any known form of human life. Despite these changes, the descent does not end, as there is no solid boundary to provide a stopping point. Instead, the environment continues to evolve, becoming progressively darker, hotter, and more compressed, marking transition from the upper atmosphere into the deeper interior regions of the planet, where the true scale of Jupiter's physical extremes begins to fully manifest. At greater depths within Jupiter, all remaining external light disappears completely, leaving an environment defined by total darkness and dominated entirely by pressure and heat. The absence of visual reference points eliminates any sense of direction, while the surrounding forces become the only perceptible aspects of the environment, increasing continuously as the descent progresses. Pressure reaches levels far beyond those experienced anywhere on Earth, rising from tens to hundreds and eventually thousands of times the atmospheric pressure at sea level. Under such conditions, materials behave differently, structures compress, and any form of biological organization becomes unsustainable. The forces involved are not sudden but cumulative, building steadily until they exceed the limits of physical stability. Temperature continues to rise in parallel, reaching levels that would be instantly lethal under terrestrial conditions. This heat is not localized but pervasive, surrounding all matter uniformly and eliminating any possibility of thermal equilibrium. The deeper regions of Jupiter act as a reservoir of energy, generated both by residual heat from the planet's formation and ongoing gravitational compression, ensuring that the thermal gradient increases continuously with depth. As the descent moves further inward, the nature of the surrounding material begins to change in a fundamental way. Hydrogen, which exists as a gas in the upper atmosphere, is subjected to pressures so extreme that its atomic structure is altered, transitioning into a state known as liquid metallic hydrogen. In this phase, hydrogen exhibits properties typically associated with metals, including high electrical conductivity, contributing to the generation of Jupiter's powerful magnetic field. This region represents one of the most extreme physical environments in the solar system, where pressure reaches millions of times of Earth's atmosphere and temperature remains extraordinarily high. Under such conditions, conventional distinctions between solid, liquid, and gas begin to lose meaning, replaced by states of matter that exist only under extreme planetary conditions. Any structure entering this region would be subjected to forces that act uniformly in all directions, compressing it continuously until its internal bonds can no longer maintain integrity. There is no distinct moment at which this process occurs, but rather a gradual transition in which increasing pressure and temperature combine to eliminate all structural coherence. Far below, theoretical models suggest the presence of a dense core composed of heavier elements, possibly rock and metal, although its exact composition remains uncertain. This core, if it exists, lies beneath layers so extreme that reaching it would require surviving conditions far beyond current technological capabilities, making it effectively inaccessible. Viewed from a distance, Jupiter presents a striking contrast to the environment within, appearing as a smooth, luminous sphere with gentle color gradients and slow, graceful motion. This outward appearance conceals the violent and complex processes occurring beneath the cloud tops, where energy, pressure, and motion interact on a scale unmatched by any terrestrial experience. Jupiter does not require a solid surface or a sudden impact to demonstrate its destructive potential. Instead, its vast atmosphere alone provides a continuous gradient of increasing extremes, ensuring that any descent leads inevitably into conditions that surpass all limits of survivability. The absence of a clear boundary or endpoint transforms the concept of descent into an unbroken process, defined not by arrival but by continuous progression into more extreme states. In the broader context of the solar system, Jupiter serves as a reminder of the diversity of planetary environments, illustrating how variations in mass, composition, and internal energy can produce worlds that operate under entirely different physical regimes. Its immense scale and dynamic atmosphere make it both a subject of scientific interest and a powerful example of the forces that shape planetary systems. Ultimately, Jupiter remains a world that cannot be experienced directly, only observed and studied from a distance, where its beauty is visible, but its true nature remains hidden beneath layers of gas and energy that extend far beyond any point that can be reached or endured.